Toyota's vision for a future sustainable hydrogen society recognizes the value of hydrogen as a viable and plentiful resource for carrying and storing energy. It has the potential to deliver zero-carbon mobility, not just in road vehicles, but equally in trains, ships, and planes, and to generate power for industry, businesses, and homes. It's also an efficient means of storing renewable energy and can be transported to where it's needed. This is why Toyota has now come up with a new hydrogen-powered vehicle that will beat every other automaker. Hey everyone, welcome to our channel. In today's video, we are going to talk about Toyota's new hydrogen car that will shock the entire car industry. So, let's get started. Toyota began development of a hydrogen fuel cell electric vehicle in 1992, successfully introducing the Mirai sedan to world markets in 2014. This breakthrough achievement was founded on the company's world-leading experience in hybrid technology, the core technology for a wide range of different electrified vehicle powertrains. The basic concept of hybrid power was successfully been adapted to produce fuel cell electric vehicles, or FCEVs, starting with the Mirai. FCEVs are ideal for larger and heavier passenger cars, heavy-duty vehicles, and public transport. Now a new generation of Mirai is being launched, a car that takes FCEV technology to a higher level and offers more emotional customer appeal in terms of dynamic, contemporary styling and more rewarding driving performance. A comprehensively redesigned fuel cell system, intelligent packaging, and aerodynamic efficiency help extend the driving range to around 650 kilometers, with no other emissions than pure water. Amazing, right? News of the new Mirai came just 2 weeks after Hydrogen Mobility Ireland, or HMI, announced a multi-week in-service trial of a fuel cell electric bus in the Dublin area. This will be the first ever hydrogen fuel cell electric vehicle, or FCEV, powered by a 60-kilowatt Toyota Mirai fuel cell stack. The trial looks to demonstrate the many practical uses and environmental benefits of hydrogen toward a carbon-free society. So, how does this new vehicle clean air as you drive? The environmental benefits of driving the Toyota Mirai go beyond zero emissions to negative emissions, as the car effectively cleans the air as it moves. A Toyota innovation, a catalyst-type filter, is incorporated in the air intake. As air is drawn into the vehicle to supply the fuel cell, an electric charge on the non-woven fabric filter element captures microscopic particles of pollutants, including sulfur dioxide, nitrous oxides, and PM2.5 particulates. The system is effective in removing 90 to 100% of particles between 0 and 2.5 microns in diameter from the air as it passes into the fuel cell system. In addition, in developing the new Mirai, Toyota has committed to delivering all-round improvements to increase customer appeal, from its performance capabilities to the way it looks and drives. A priority has been to improve its driving range compared to the first-generation model, and going beyond the distances typically achieved by battery electric vehicles. Increased power and hydrogen fuel capacity, improved efficiency, and better aerodynamics all contribute to extending the driving range by 30% to around 650 kilometers. This gives the new Mirai a genuine long-distance driving capability. Moreover, packaging has also been significantly improved with the new Mirai built on Toyota's modular GAL platform. This platform is already in use in the top-of-the-range Lexus LS, a more efficient and well-balanced arrangement of the new FCEV powertrain. Notably, with the fuel cell stack moved from beneath the cabin to the front compartment, has allowed for a more spacious 5-seat interior with improved legroom for rear-seat passengers. The new Mirai also displays more attractive vehicle proportions, as the overall height has been reduced by 65 mm to 1,470 mm, and there is a 140 mm increase to the wheelbase. With the rear overhang extended by 85 mm, overall vehicle length is now 4,975 mm. A 75 mm increase in the track width and the use of larger 19 and 20-inch wheels add to the lower and more dynamic stance and visual sense of the new Mirai's lower center of gravity. So, apart from technical things, what else is attractive about the new model? One of the principal aims for the new Mirai has been to give the car a stronger emotional appeal, making it a car that people will be attracted to by its looks and the way it drives, as well as eco-performance. The new GAL platform and Toyota's advanced FCEV technologies have made this possible. Adopting the GAL platform has allowed the fuel cell stack and drivetrain components to be repackaged in a way that makes more efficient use of space. The result is a more spacious 5-seat cabin and a better chassis balance. Perhaps most significantly, it enables 3 high-pressure hydrogen tanks to be fitted, increasing fuel capacity and the car's driving range by 30%. The tanks are arranged in a T configuration, the longest running longitudinally and centrally beneath the vehicle floor, with two smaller tanks set laterally beneath the rear seats and the luggage compartment. Together, they can hold 5.6 kilograms of hydrogen, compared to 4.6 kilograms in the current Miry's two tanks. Their position contributes to the car's lower center of gravity and avoids compromising load space. The new architecture also permits the all-new hydrogen fuel cell to be moved from its current location beneath the floor to the front compartment, while the high-voltage battery and electric motor are positioned above the rear axle. Apart from this, Toyota's new fuel cell stack and fuel cell power converter, or FCPC, have been developed specifically for use with the GAL platform. The designers have been able to bring all the elements together in the stack frame, including the water pumps, intercooler, air conditioning, and air compressors, and the hydrogen recirculation pump, with each part made smaller and lighter, while at the same time improving performance. Focusing on innovation and improvement in every component has delivered a 50% weight reduction, yet a 12% increase in power. New measures include relocation of the manifold, reducing the size and weight of the cell, optimizing the shape of the gas channel separator, and using innovative materials in the electrodes. The unit also incorporates the fuel cell DC-DC converter, or FDC, and modular high-voltage parts, while achieving a 21% reduction in size compared to the current system. Weight has been cut by 2.9 kilograms to 25.5 kilograms. Advanced technology has contributed to the space saving, with Toyota's first-time use of the next-generation silicon carbide semiconductor material in the Intelligent Power Module, or IPM, transistors. This enables an increase in output and lower power consumption while using fewer transistors, which in turn allows the FCPC to be made smaller. The same size and weight-saving approach has been applied to other parts of the FC stack. The air intake is designed for lower pressure loss and contains sound-absorbing material so that noise from the air inlets is unnoticeable in the cabin. The exhaust uses a resin pipe and is designed to allow for a large amount of air and water to be discharged. A larger capacity silencer contributes to the quieter cabin. The complete air system is almost 30% smaller than the current Miry and weighs more than a third less. Furthermore, the new Miry is equipped with a lithium-ion high-voltage battery in place of the current model's nickel metal hydride unit. Although smaller in size, it is more energy-dense, giving higher output and superior environmental performance. The battery's smaller dimensions have allowed it to be positioned behind the rear seats, avoiding intrusion in the load compartment. An optimized air cooling path has been designed, with discrete inlets on either side of the rear seats. Talking about its dynamic performance, the adoption of the GAL platform for the new Miry gives the car fundamental benefits of lowering center of gravity, improved inertia characteristics, and significantly increased body rigidity, all of which help deliver superior dynamic performance. The rigidity of the body has been increased with strategic bracing and reinforcements, and wider application of body adhesives, and the use of laser screw welding. The new platform also accommodates new multi-link front and rear suspension, in place of the previous front McPherson struts and rear torsion beam arrangement. The setup provides a high level of stability, controllability, and ride comfort. Details include the use of thicker anti-roll bars, optimal upper and lower ball joint location, and overall high suspension rigidity, yielding rewards in terms of responsiveness and stability. Therefore, the car's improved aerodynamics with a lower roofline, full undercover, and lower drag coefficient figure plays its part too in rising the quality of handling and stability, and achieving the longer cruising range. And this is it for today, guys. What are your thoughts on today's video? Let us know in the comments section below. And if you liked this video, don't forget to give it a thumbs up and subscribe to our channel. And thank you for watching.